And then I would suggest you use sign analysis so we will not go wrong. You guys bring in sign analysis. I see a -2 and a +2 coming out for my critical numbers. They're open. And you're supposed to go through and test and see where to shade. To save me a little bit of time. Well, let me go into it. You're supposed to go out here. You can see it. Here. Here. Doing all this by sign analysis. Guys, my test point out here, I'm going to try -4. In between, I think we'll try 0. And out here, we'll try a 5. I'll try -4 right here. Place next by -4. 2 subtract a -4 is going to turn into a +6. 2 plus a -4 is going to be a negative. And a positive times a negative is going to give me a negative, and that's not what I want here. In between 0. 2 subtract 0, of course, is 2, which is positive. 2 plus 0, another positive, and that's exactly what I want. So this is the interval in which I'll shade. 5, I doubt it works, but here goes. 2 subtract 5 is a -3. 2 plus 5 is a +7, and it's not going to work. So my domain, guys, after all that, in interval notation would be open, -2, up to 2. So it took a little bit of work there. Okay, part B. Anytime you want to respond, please slow me down, guys. Next one says, find the domain again, h of x. And this one is square root x subtract 3 over x squared subtract 5x plus 4. That one's the domain. Okay, let's deal with that square root part first. That square root, to find the domain, the part underneath there, the radicand they call it, must be that. You can't take the square root of a negative. So underneath there must be a positive or 0. Which implies x must be at this point this. X must be greater than or equal to 3. At the same time, I know and you know, the denominator cannot be 0. That cannot be 0. By the way, there's factors, which may help me. And I can write quickly in that factored form, you cannot let x be 4 or 1. You guys agree? Now put all that together, write in interval notation please for me, and I'm going to use both parts. This part, and if you think about it, guys, x is greater than or equal to 3, you're going to bracket 3, and I think I go up to 1, 1's not supposed to be included. Union, looks like 1 up to 4, union, let me see if you guys will agree, 4 through infinity. Is that the conclusion? Bracket 3, up to 1, I can't use 1, union, then go from 1 up to 4, can't use 4, then 4 through infinity. Is that the full statement?
Would it be bracket 3, comma 4, union 4 to infinity? Since it can't be 1?
Oh, okay, hang on. Michael, let's do this. Let's do an illustration. It says you may use anything to the right of 3. Let me show that like that. That takes care of that. Right? But I can't use 1 or, I'll see what you guys are looking at. 1 or 4. You say, wait, Professor, 1's over here. Is that what you're telling me? Mm-hmm. And 4 is here. You say, sure enough, Professor, you can use 1, but is 1 caught within that black? So you're saying right here, that's what I want you to see here. So you're saying, hold on here. Should I go from 3 up to 4? This is right now. Michael, tell me what's happening here. And then 4 through infinity? Mm-hmm.
Thank you.
And the illustration is the illustration showing that. That's why I ask you guys to agree with that, because I like the illustration myself. And that makes the statement agree exactly with what Michael says. You know, guys, I can't let x be 1, but 1's down here, to the left of 3. That's not going to play a part. Are we okay, guys? Did I have one more domain? Oh, I did. Yes, number 3, letter C. We have j of x. Looks like it's inverse cosine x. I want the domain, which is right there. Step back and look at what we've done so far. Whew. Okay. Think about it. Someone tell me what you think it is, and we'll talk about it.
0 to pi included.
I know what you're thinking. I know exactly what you're thinking. You got that 0 to pi in your mind. That's more of restriction on the outcome, the range. I want to know what can I replace x by. Who has an idea? Inverse cosine x. Michael, I know what you're thinking. You're saying, Professor, I remember in class the restriction was something like a 0 up to pi, wasn't it? Inclusive, I think it was. That's true? That's not the domain.
-1 to 1.
-1 to 1.